We've now seen a bunch of examples of recursive functions. We've seen some of the power of that. We keep coming back to this idea of break a problem down into smaller versions of the same problem. Really great way of trying to tackle a problem. We're going to do one last thing, and that goes back to when we ran Fib. When we ran Fibonacci, we might have noticed that as we made the arguments larger and larger, it slowed down, which is not surprising. It's calling itself multiple times. And suppose we wanted to actually count the number of times that Fib called itself recursively. Multiple ways of doing it, but one of the ways in which we can do this is to use what's called a global variable. What does that mean? Well, so far, all the functions have communicated with their environment strictly through their parameters and their return values. That is, when we call a new function, it creates an environment with some parameters passed in, it does some work internally, and it returns a value as the value of its response. We can make a variable or declare a variable to be global. And what this means is that the name is defined at the outermost scope of the program rather than the scope of the function within which it appears. It's global because it's going to appear up at the top level. It's going to be part of what we want to deal with when we're interacting with, for example, the Python shell. As it notes here, this can be a bit dangerous, and we'll talk about that in a second. But let's just look at how we might do this. So, here's the idea. We're going to call this a metered version of Fibonacci. It has much the same form as before. There is the recursive call just as we had before, using a different name, of course. But we do two things. Right here, we make a declaration that says the variable numCalls is global. That means it's going to be bound way up at the top, at the highest level environment. Inside of Fib metered, we're going to actually change numCalls. This says every time we call Fib metered, we're going to increase that global variable by 1. Great, so that's going to count how many times it's called. We can test this with a little test script here. I'm going to run Fib for some number. I'm going to have I go over from 0 up to n. And notice what I'm going to do. Each time I go through the loop, I'm going to again say numCalls is a global variable. It's defined up in that top level place. And I'm going to set it to 0. That is going to have the effect of, in the global environment, changing numCalls to 0. And then I'm going to actually do some work and print out some results. Okay? I'm going to do the work of figuring out what Fibonacci is. The call to Fib meter will, every time it calls it, change numCalls by 1. And when I'm done and when it returns, I can print out how many times was that actually called. Okay, let's see what happens if we do this. So I'm going to go over and start up over here inside of my idle environment. And if I load that in, let's actually do a test on Fib. And just for ease, we're going to do it up to 5. And it now tells us, oh, cool. When I call a Fib on 0, the answer is 1. It was called 1 time. Makes sense. When I call Fib on 1, the answer is 1. And it was also called 1 time. We knew those were the base cases. And then you can see the responses as we move up. So let's make this a little bit bigger. Let's do test Fib. Oh, well, let's make it up to 20. And we'll see what it does here. You see it's moving pretty quickly. It's starting to slow down a little bit, but we're actually now calling test Fib in that metered form, and it's showing us how many times it's called. Also notice, if you look at the numbers, it's clear that we're resetting numCalls each time around, and that, if we go back to our slides, came from right here. Each time through the loop in test Fib, we reset numCalls to 0 up in that top environment, so that when we go ahead and call Fib metered, it is starting from 0 and doing the count for each time it calls recursively within itself. A nice tool, a tool that's really kind of handy, and something that we'll come back to because it is a way of being able to keep track of some things. But I want to finish with a couple of comments. First one is use it with care. Putting a variable as a global variable is destroying the locality of the code. One of the beautiful pieces about recursive code is all of the function call contains within it all the information it needs. The parameters passed in, it does all the work internally, locally, and it simply returns a value back out. That is an elegant way of being able to not only think about what's going on, but to be able to deal with the code. Once we have global variables, they can be modified or read in a wide range of places, and that's going to make it really easy to break the locality, especially if some place outside of the function we're dealing with makes a change to a global variable, and that affects the computation inside that local call to a procedure. This is going to allow the potential for introducing bugs. And most computer scientists will be very strong about arguing that one should not use global variables if at all possible. It is much better to encapsulate the computation locally. But here's an example where we're metering things, where having a global variable can be really handy.